some more of these graphing problems, and this is number 13. And I use this window again, so -3 to 3, -2 to 2. I use my step to be, I think, 0.1. 0 to 2 pi, and t-step would be 0.1, so we have a relatively smooth curve. So let's graph this one, and that's going to be 2 cosine of 3 theta. All right, so I guess you can see that there. Put that in and graph it. Ooh, it looks like a rose. Okay. So I have to sketch this. It kind of goes out to 2. This is going to be out to 2 also, but it's going to be at that angle. So we have to kind of look at our calculator and then try to kind of match it. So in our window, it's like this 1, 2. So it looks like it's going to go like this, and it's going to curve down like this. And this is going to go up here, something like about this, so just try to make it the same thickness there. It looks like it's going to be a rose, so you want to make all your petals the same, and this will go down over here. And something like that. Okay, it's not going to be perfect. And again, that's a rose, 3-petaled rose. Okay, so just get something like that. So try to sketch it. And there's nice formulas for those to determine how many petals they have. And if you do a lot of these, you can see the angles that they're going to be out and do a little bit better job. Okay, and then number 15, r equals 1 minus 2 sine of theta. So let's graph this one. It's the same window, I guess. I did -4. Brought this out a little bit more, so I'll change my window. -4. And graph these in -3 to 3, so -3 to 3. I already graphed these, so I knew what the window would be. So let's go back over here and graph it. But when you graphed it, if it wasn't fitting right, then you could change your window. So 1 minus 2 sine of theta. Oops, graph. And see, it looks like a cardioid with a little loop in it. Okay. So it's a cardioid again. Well, actually, what we call a lemicon. Excuse me, not a cardioid. So the lemicon's it's in that form. It's got a little circle in it. Cardioids. Well, the cardioid is a special lemicon. Excuse me. It's a lemicon. The cardioid is just with a little thing like this. So it's a lemicon. A cardioid is a lemicon, but not all lemicons are cardioids. So this is going to come down. Looks like it's going to go down to 1. So this little loop in here will be like this. It's going to come down like this. That's going to be quasi-circular, so it's going to go all the way down here to 3, so it's going to curve around like this. And this should probably be a little I'm looking at my graph here. That's kind of the hassle with these because, you know, so you want to use your eraser and everything, kind of try to do a little bit better. That's a little flatter, so I'll erase that. So you're just going to have to fiddle around with them a little bit. So that'll be a little bit closer like that. Get a little more curvature down here, a little bit closer like that. A little more curvature there. And see if you fool around with it, eventually you'll get it to look a little bit, you know, more and more like your calculator. Too bad you just can't transfer it over there, but they want you to sketch it. So there's our Limicon. Now that's I'm going to be satisfied with that there. This should maybe be a little bit like this, maybe something like that. Okay. So Limicon, cardioid's a special Limicon, cardioid, and then a general Limicon. M-A-C-O-N, Limicon. Okay. So hopefully that rendition is pretty close. That's 13 and 15. Okay.